Hey guys, welcome back. In this video we're going to work out question 9 part A of the CXC CSEC Math January 2012 paper 2. This is a question actually in section 2 where I've completed all the videos for section 1. That's questions 1 to questions 8, and I hope you've been watching those videos and I hope they've been helpful to you. So moving on to question 9, let's see what it asks. It's actually a question from the algebra and relations, functions and graphs um, part of the section. And it says, the first part we want to make x the subject of the formula where y is equal to 2x plus 3 all over x minus 4. Second part, hence determine the inverse of the function f of x equal to 2x plus 3 over x minus 4 where x is not equal to 4. And then the third part, find the value of x for which f of x is equal to 0. Okay, so I already worked this question out, and this is the working for the question, and this is the working for part 1 of the question, and these are the steps. So let me just go through the steps and explain why I did what I did. So this is the formula. This is the quote-unquote formula we're given, y equal to 2x plus 3 all over x minus 4, and we want to make x the subject of the formula. What that means essentially is to get x on one side of the equal sign and everything else on the other side. So eventually we want to end up with something like this, where x is on one side and everything else is on the other side. So how do we get there? Well, the first thing I did was to multiply throughout by x minus 4. By doing that, the x minus 4 will cancel here, leaving 2x plus 3 on the left hand side and y times x minus 4 on the right hand side. So that's this part here. The second thing was to expand the brackets, so I multiplied x minus 4 by y, giving us x times y minus 4 times y equal to x plus 3. This remains, the right hand side remains the same. To get from this step to this step, I added 4y to both sides and I subtracted 2x from both sides. So I got xy minus 2x equal 4y plus 3. If you look at the left hand side, you'd notice that x is a common factor, so I took that out, leaving x times y minus 2 equal 4y plus 3. Finally, I chose to divide both sides by y minus 2. Now I couldn't do that just because remember y could have a range of values, and we're not sure if one of the values, so for example when y is equal to 2, this expression would evaluate to 0, and so dividing by y minus 2 in that case would mean I'm dividing by 0, which I cannot. So I had to stipulate that y cannot be equal to 2 if I'm going to perform this operation. If I'm going to divide both sides by y minus 2, then y cannot be equal to 2 because I'll be dividing by 0, which you cannot do. Okay, so that last step gave us x is equal to 4y plus 3 all over y minus 2. And again, the stipulation that y cannot be equal to 2. And this here is, this final part here is what we call making x the subject of the formula, or writing x in terms of y. Okay, the second part says hence determine the inverse of f of x equal 2x plus 3 x minus 4. Well, these steps that we went through here in the first part are precisely the steps that we need to go through if we are to find the inverse of a function. Right, so initially we had y in terms of x, and if we want to find when we find x in terms of y, or make x the subject of the formula, what we have essentially done is found the inverse function. We have a function that given x gives us y, but now we have at the bottom here a function that given y gets us a value for x. And let's just check a value to see if we actually do have the inverse. Right? So the inverse is supposed to work in this way. If we have a value for x, let's say some value for x where x is equal to a, and we put that into the function and we get b, then the inverse function is supposed to work as follows. If we put b into the inverse function, then we're supposed to get back a. Let's see if that works. So let's suppose a is equal to 5. Then f of 5 is equal to what? F of 5 is 2 times 5 is 10 plus 3 is 13, and 5 minus 4 is 1, so we get 13 over 1, which is 13. Now let's put that into the inverse. Let's put 13, remember this is our b, let's put 13 into the inverse function and see that we get back 5. Well, by doing that we get 13, so b is equal to 13, and f inverse of b, f inverse of 13, we should get back 5 here, right, if this is really the inverse function. 13 times 4 is 52, right? 52 plus 3 is 55, and 13 minus 2 is 11. 55 divided by 11 is indeed 5. Right? So this function, at least it works for when a is 5, right? So, and in general, it does work for all the other values. We do get this relationship happening for all the other values. So this function here is indeed the inverse function, the inverse of f of x. Part 3. Find the value of x for which f of x is equal to 0. Well, f of x is this function here, and when f of x equals 0, let me clear the screen. When f of x equals 0, what we have is 2x plus 3 all over x minus 4 equal to 0. Now, if this expression is to be equal to 0, it means 2x plus 3 has to be equal to 0. Right? X minus 4 cannot be equal to 0 because we cannot divide by 0. And dividing any number by a non-zero quantity will never give you a 0. So the only way this could be equal to 0 is if 2x plus 3 is equal to 0. So this implies then that 2x plus 3 is equal to 0. Right? The same implication we reached when I worked it out here. And so x then, so then 2x is equal to negative 3, right? We get this by subtracting 3 from both sides, and then dividing by 2 on both sides, we get x is equal to negative 3 all over 2. And that's it.